Hello! In this video, I'll just review some of the standard I/O redirection commands that I explained in our previous video. Here we are. If you remember from our first Unix shell, we ended up at Python for Data Science, my first directory folder, like it's a directory we created. And I can see that by typing pwd. I can also ls in this directory and see the contents of it. And as you might remember, we had two files, fruits.txt and shakespeare.txt. We moved into this directory. Now I'll use the cat command to display the contents of fruits.txt. And I see that there's about 8-9 lines in there. If I do the same thing to shakespeare.txt, we'll notice something interesting actually here, that it's not going to fit in the shell. So it's going to quickly go through the file, all the 12,000 something lines in this file, and it's going to bring me back to the end of it, and I'll only see the end of the file. How do I get around this problem? There's another command called more in Unix. And as you might remember, the man command is yet another command in Unix to look up the manual pages of all these commands. So if I say man more, I'll see the description of the more command, for example. Or if I say man cat, I'll see the description of the cat command. So if I say man more, I'll see that this command is going to give me however much fits in my Unix shell. So I can, instead of cat shakespeare.txt, I can say more shakespeare.txt, starting from the first line that starts with this is the 100 etext file, blah, blah. I'll see however much fits in my shell about that shakespeare.txt. So by just pressing the space key in my keyboard, I can go through this file and look at all the lines in this file. Or I can just get out of it using Q. So then there's a difference, right? We said cat shakespeare.txt, it goes through the whole file. We can't see the beginning of the file. We can, of course, scroll back up using our mouse, but we don't want that. And we can also say more shakespeare.txt and see the file as much as fits in our shell. So why is this useful? Because we want to go through the file. And sometimes these longer files, we want to do something with it, right? We want to maybe sort this file or count the lines in this file. So let's say I want to sort the contents of fruits. Sort is a Unix command. We can use it for quick data manipulation. I'll say sort fruits.txt. I'll see the contents of fruits.txt all sorted in alphabetical order. So now I'll take the sorted file, fruits.txt, and I'll save it to yet another file. The thing to use here is the standard out redirect greater than symbol. And I'll call that file fruits sorted.txt. So I don't see anything in my standard out because I redirected the standard out to this file. If I cat fruits sorted.txt, of course we can just give the file name to the cat command as you've seen before, or cat actually can accept the input to come from a file that's redirected to it, like fruits sorted.txt. Here I'm doing an input redirection, standard in redirection to come from fruits sorted.txt. I would see the contents of that file. So it's the same with the standard output of the command that we've seen before. So the next thing I'll do here is to actually manipulate this file even more and get only the unique lines in this file. So I can look at fruits sorted.txt and get the unique lines in it. So here we see double apples, double peaches gone now. We only have apples, grapes, melon, oranges, peaches, and strawberries. 6 lines there. So there are 6 types of fruits, unique fruit names in this file. If I'd like to save that to another file, I'd say unique fruit sorted.txt and redirect the output to fruits unique.txt. So I can quickly cat the contents of fruits unique. We see that it's the same with the standard output of the command. If I ls now into my directory, I'll see 4 files. Instead of just fruits.txt and shakespeare.txt, I'll see fruits sorted and fruits unique.txt. Why would this be useful? Because there's a lot of Unix commands that I want to quickly save the outputs to a file and maybe count them. In this case, how would I count the number of unique fruits? That would be counting the number of lines in fruits unique.txt. And if you would remember from our earlier video, WC command has a -l option to give us just the number of lines in that file. So I would say WC -l or -l and fruits unique.txt. It's going to give me 6 as the number of the lines. So there are 6 unique file names in the fruits.txt, in our original fruits.txt. So you could see that we are already doing some data exploration using Unix commands. Right? We had a file with a bunch of fruit names. We wanted to see how many unique fruit names are in that, or we could see the sorted options of that. So we are doing something with this. If we treat that file as a data set, we are manipulating that data and exploring with it a little bit. So I could also use this command. Let's say I could use the who command in Unix. It shows me how many or who are logged into the Unix system I logged in at that time. If I just say who, I'll see 3 alternatives because I have 3 shells open. I can just say redirect the output of this command into a file called names.txt. And I see here that all these names are saved into names.txt in my shell. How would I use that? I might maybe go through that and email all the users logged into the users at that time. There are lots of Unix commands that take advantage of the standard in. After this, maybe I would say I would give these names as a standard input to another command and get those names and maybe use the mail command to send a standard message to these users. And things like that. I can actually manipulate these files. And by redirecting the right outputs to the right files, I can use that as to generate a data set for using in yet another operation. But how do redirects work? Another thing I want to show you is groups of commands executing together and redirect applying to the command that it gets coupled with. To command 2 strings together, I can say pwd and then execute ls-l right after that. If I use the semicolon operator or character after pwd, it says execute pwd, and right after that execute ls-l. It's like typing 2 of these commands one after another on the shell. So I'll see 2 outputs here. Right? I'll see the output of pwd, and then I'll see the output of the ls-l operation that we just typed. Now let's say I want to redirect the output that I've seen from these 2 commands into a file called out.txt. Just think a second, what would you expect to see in the standard out? What you will actually see is the output of the first command, because this redirect operator here with out.txt only applies to the command it's bundled with. If you want all of these outputs to go into out.txt, both pwd and ls-l outputs, we'll put them in a parenthesis. So I can say ls-l and then redirect that to out.txt. And now, if I cat out.txt, I'll see all the outputs of these 2 commands were redirected to that out.txt. So we are actually creating a composite command with by stitching together these two commands and putting them in those parentheses. There is one last interesting thing I'd like to show you about a construct in Unix that we use. We can actually suppress these redirected outputs by sending it to the null device. It's like /dev/null. So in this example, I could have just said, instead of out.txt, I could have just said, send the output to dev/dev/null, to dev null. And it's not going to go anywhere. It's just going to be ignored. It's not going to be seen on standard out, and it's not going to go to a particular text file. So there's a Unix programmer's joke. If you want to ignore somebody, you would just tell them, I'm redirecting you to dev null, and this is where this comes from. So we just reviewed standard I/O and redirections. I hope you'll be able to exercise with these redirects more on your own. And in the next video, we'll review some other interesting Unix features.